you will need your polyatomic ion list. So it's the untitled worksheet and then the polyatomic ion list. So what we're going to do today is work on writing ionic formulas from the names. And let me share my screen. So I'll post this to Canvas too. I didn't post it yet, but I will. But writing ionic formulas from names involves you using some resources, and it depends on what type of what is in the name. So the process, of course, we write cations first. So the cations are listed first in the name. And you have to see whether or not you have a Roman numeral. If you do not have a Roman numeral, you have to look up the cation's charge on the periodic table. And I'll show you a periodic table with the charges in a second. If you have a Roman numeral, the Roman numeral indicates the charge of the cation. And then, so you look up your charges of your cations. And then the second part is you look at the anions ending. If the anion ends in IDE, except hydroxide. Hydroxide is a polyatomic ion. But if the anion ends in IDE, then you look up the anion's charge on the periodic table. Now the anions are going to be on the right side of the periodic table. If the anion ends in ATE, it's a polyatomic ion. So you look up its formula with its charge on your polyatomic ion sheet. And then once you look up the charges, once you've got your formulas of your polyatomic ions and your charges, all you have to do is do what we've been doing the past 2 days, where you swap the charges and indicate the number of each ion. And if you need more than one polyatomic ion, it goes in parentheses. So we've got this periodic table, and on the periodic table we have a certain pattern to the charges. Every element in the same column is going to have the same charge. So we've got column 1 is a +1 charge. Column 2 is a +2 charge. You skip over the middle, what we call the middle. The middle is the transition metals. Columns 3 through 12 are the transition metals. And like I said before, if you have a Roman numeral, you have a transition metal, and then the transition metal charge is given by the Roman numeral. except silver and zinc, Ag and Zn. And I'll write this on your on the whiteboard when we get there. But Ag is a +1 and Zn is a +2. But those are the only transition metals that have a set charge. And then we get to column 13. Column 13 has a +3 charge. We're going to skip column 14. And then column 15 has a -3 charge. Column 16 has a -2 charge. Column 17 has a -1 charge. And then column 18 has a 0 charge. So with that in mind, we need to write these formulas. So let me share my screen again. So with the worksheet, I wish I could pull up the periodic table to overlay on this, but I can't. With the worksheet, we've got calcium, chloride. So what we have to do is look up the charges of calcium and chloride. We don't have a Roman numeral, so we don't have to worry about that. So calcium is in column 2 of the periodic table. So calcium is going to have a +2 charge. And then chloride is chlorine. So Cl, it ends in IDE, so it's a monatomic anion. So we look up the charge of the periodic table. So chloride comes from chlorine, which is a -1. And then all we have to do is do what we did yesterday, swap the charges. The 1 goes with the Ca, the 2 goes with the Cl. So this will be CaCl2. 2 calcium nitride. So calcium is in column 2, so it's a +2 charge. Nitride, it's ends in IDE and it's not hydroxide. So nitride is nitrogen and it's in column 15. So it has a -3 charge. And so we've got to swap charges. And we've got Ca3N2. 3. sodium fluoride. Sodium is in column 1, so it has a +1 charge. Fluoride is in column 17, so it has a -1 charge. And then these both have a -1, a +1 and a -1 charge. So we don't have to crisscross the charges. All we have to do is write the formula with 1 ion apiece. So that would be NaF. Okay, moving right along. 4, magnesium oxide. So magnesium oxide, magnesium is Mg, and it's in the second column of the periodic table, so it has a +2 charge. Excuse me, oxide comes from oxygen, which oxygen is in column 16 of the periodic table, so it has a -2 charge. And then here we see that they are both 2s, so we don't have to swap the charges. All we have to do is write the formula with 1 ion apiece. So that would be MgO. All right. Now, let's look at numbers 13 and the rest. Thirteen is nickel 2 sulfide. Now, here we cannot get the cation's charge from the periodic table. But we do know the cation's charge. This too is the charge of your cation, of the nickel. So this would be nickel +2 because of the Roman numeral 2. And then sulfide is in column 16, so it's a -2 charge. So then we've got +2 and -2, they're both 2s, so this would just be NiS. All right. And then 14. chromium, three, bromide, we've got Cr, and then the Roman numeral indicates the charge of the Cr, so it's a +3. And then bromide is in column 17, it's a Br -1. Crisscross the charges, so we get Cr, Br, 3. We'll skip number 15. And then 16, and then we will go to the right side of the worksheet, copper 2, bromide. Alright, so copper is Cu, and then the 2 means that the Roman numeral 2 means that copper is a +2, and then bromide's in column 17 again, so it's a -1. Swap your charges, and we get Cu, Br, 2. All right. So then let's jump over to the right side of the worksheet, and we get 26. Sodium hydroxide. Now, this is one of the exceptions where the IDE ion does not come from the periodic table. You have to pay attention when you have hydroxide, because hydroxide is a polyatomic ion. So sodium is Na +1, and then hydroxide, you look up what hydroxide is on your polyatomic ion sheet, and when you look on your polyatomic ion list, you'll find that hydroxide is OH -1. So Na +1 and OH -1, they're both ones, so all we have to do is write the formula without subscripts. This would be NaOH. Sodium nitrate. sodium is Na +1. Nitrate, it ends in ATE, so that means that you have to look on your polyatomic ion list. Nitrate is NO3 -1. So sodium nitrate is going to be NaNO3. Barium. Hydroxide. Barium is Ba. It's in column 2 of the periodic table. So it's a +2. Hydroxide is OH -1. And so we have barium hydroxide. We swap the charges. Here we will need 2 hydroxides. So we need to put the OH in parentheses and put a 2 outside of the parentheses. And then I think we have time for a couple more. Let's see. Let's do 43. Copper 2 phosphate. Let's see. So Cu, now recall that the 2 means that the copper is a +2. Phosphate is the polyatomic ion because it ends in ATE. So phosphate is PO4 -3. Swap the charges. And we get Cu3 and then PO4 2 in parentheses. PO4 is in parentheses. So are there any questions? Okay. So what we'll do tomorrow is we will have a little bit of time to